Welcome to my presentation. In this presentation, we shall see how to solve exponents using laws of exponents. Okay, so let us look at some simple examples. In the first example, let's say we want to simplify this expression here, 10 to the power of negative 3 times 10 to the power of positive 2. So in here, we will break it down into these different steps to arrive at the solution. So step number 1, we're going to use the product rule, and the product rule is telling us that if the bases are the same, we can write the base once and then we can combine the powers. So 10 to the power of negative 3 times 10 to the power of positive 2. Since the bases are the same, we're going to write the base once and then we'll combine the powers, negative 3 plus 2. So this we can write as 10 to the power of negative 1. So we can write the same thing as 1 over 10 to the power of positive 1, same thing. The 10 to the power of negative 1 in the numerator, when we write it in terms of a positive exponent, we can write it as 1 over the same number but with a positive number, but with a positive sign. So therefore, 10 to the power of positive 1 or 10 to the power of 1 to the power of 10 means exactly the same. So therefore, this is where we want to leave it. This is our answer. 1 over 10 is the simplified form of the product of 10 to the power of negative 3 times 10 to the power of 2. Let's look at another example. That was a simple example. Let's say we have another example, and then in here we want to simplify this expression, 2 to the power of negative 3. This whole thing is raised to the power of negative 2. Okay, so the way we want to solve this is by following these different steps. First, we want to recognize which rule we want to use. This is in the form of x to the power of m, this whole thing raised to the power of n, isn't it? In here, instead of for x we have 2, for m we have negative 3, and for n we have negative 2. So if we were to write this one as 2 to the power of, so let me expand this, and then we can come back to this one. So x to the power of m, the whole thing raised to the power of n, we can write that as, we write the base and then we multiply the powers, m times n. So we will apply this rule to solve this particular problem. So we have 2 to the power of negative 3. This whole thing is raised to the power of negative 2. So we write the base 2 and then we multiply the powers. Negative 3 times negative 2. So the way we can simplify that is as follows. We write the 2 as the base. We multiply the powers. Negative 3 times negative 2 is positive 6. We can also write this as 2 to the power of 6. If we want to, we can expand that. I'll call this as step 2. And in step 3, we can expand 2 to the power of 6. 2 to the power of 6 is, according to what we know with relation to exponents, is the base. 2 is the base and 6 is the power term or the exponential term. The number of times the base term needs to be repeated is indicated to us in the exponential term. So therefore we're going to write this as 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. So therefore we can then come back and then simplify this. 2 times 2 is 4. 2 times 2 is 4. 2 times 2 is 4. 4 times 4 is 16. 16 times 4 is 64. So therefore 2 to the power of 6 is 64. So therefore the problem we had was 2 to the power of negative 3, the whole thing raised to the power of negative 2, simplifies to 2 to the power of 6. We can write it as 2 to the power of 6 or 64, same thing. Let's look at another example. In here, let's say this time we want to simplify we want to simplify 2 to the power of negative 3 divided by 3 to the power of negative 2, and this whole thing is raised to the power of negative 1, right? So let's say then we will try to solve this particular problem using these different steps. Step number 1. If this is in the form of a over b, the whole thing raised to the power of m, isn't it? We can write this one as every one of the terms, this is like a quotient raised to the power. So every one of the terms will be raised to that power, a to the power of m divided by b to the power of m. And that is exactly what we're going to do in this particular example. In step 2, we will write down the problem what we have, 2 to the power of negative 3 divided by 3 to the power of negative 2. This whole thing is raised to the power of negative 1. So we can write this as 2 to the power of negative 3. This whole thing is raised to the power of negative 1. We are applying the rule now. Divided by 3 to the power of negative 2. This whole thing is raised to the power of negative 1. Now, we can simplify the numerator part, we can simplify the denominator part. The numerator and denominator, they look like another rule which we talked about. If we have x to the power of m and that exponent is raised to another power, like to the power of n, the rule is telling us that we write the base ones and then we multiply the powers, m times n. We're going to perform the same operation in here, and when we do that, we're going to write the base ones and then we're going to multiply the powers, negative 3 times negative 1. And same thing in the denominator. We write the base, we multiply the powers, negative 2 times negative 1. Then we simplify that some more. So the way we can simplify that is as follows. We write the base 2 and then negative 3 times negative 1 is positive 3. And then in the denominator we have 3 to the power of negative 2 times negative 1 is positive 2. So therefore 2 to the power of 3 divided by 3 to the power of 2. We can expand this. We can expand these. 2 to the power of 3 means the number of times the base term here is 2 and the exponential term here is 3. So therefore 2 to the power of 3 means the number of times the base needs to be repeated is 3 times with multiplication. 2 times 2 times 2. And in the base, in the denominator, we have 3 to the power of 2. The base term is 3, the exponential term is 2. Therefore, the number of times the base term, which is 3, needs to be repeated is 2 times. Right? Therefore, we multiply the numerator numbers, we multiply the denominator numbers, and we should be arriving at the answer. 2 times 2 is 4, 4 times 2 is 8. Then in the denominator, 3 times 3 is 9, and therefore this is our answer. This is where we want to leave it. So therefore, the given expression, we wanted to simplify 2 to the power of negative 3 divided by 3 to the power of negative 2. The whole expression raised to the power of negative 1 simplifies to 8 over 9. So this is where we want to leave it. In my next presentation, we shall see some more examples related to solving problems using the laws of exponents.